and welcome to GW Prime Live. Your where is here. I am Nibedita Mohanta, your host for today's session, which revolves around the topic spatial computing shaping the geospatial ecosystem. Today, we are honored to have Nick Bolton, CEO Ordnance Survey, to join the GW Prime Live session. Welcome to GW Prime.
Thanks for having me. It's great to catch up again.
Ordnance Survey is Great Britain's national mapping agency, renowned for its precise and up to date geographic data. Trusted by governments, businesses, and individuals alike, Ordnance Survey plays a pivotal role in providing critical geographic information that drives decision making and innovation. Every map tells a story, weaving together humanity's past, present, and future. From the migration of our ancestors to the dynamics of political shifts, environments changes, and beyond. With the transformative power of AI, ML, and spatial computing, maps are evolving into sophisticated tools that redefine how we understand and interact with the world. The integration of large language models with intelligent agents is revolutionizing geospatial intelligence. These advancements enable seamless transformation of natural language into precise data insights, making geospatial datasets more accessible, mainstream, and user friendly. In today's conversation, we'll explore how to optimize and strengthen the geospatial value chain, the role of cross sector collaboration in deriving value from geospatial data, and much more. So, I'll start with my first question, Nick. How can we optimize the geospatial value chain to ensure a seamless transition from data acquisition to actionable insights?
Uh, well, it's something we've done a lot of thinking about actually here at Ordnance Survey. And we all probably need to try and go into that question by talking about what we mean by a value chain in the first instance. The way to think about a value chain is it's true for all organizations and all businesses. It's how you go from the ingredients that you take to create the delicious meal that you then serve to your end customers. And so you then need to understand how in that journey, how in that chain of events that you undertake, do you actually add value to take those ingredients and deliver the end product. And we at Ordnance Survey, we break that down into 5 specific areas, which I think are probably true for most national mapping agencies or any set of map or geospatial data providers. First of all, it's position. We have to know where stuff is and how we go about doing that. That covers aspects of geodesy, but it also covers aspects of GNSS systems. The second area is sourcing. So where does the data actually come from? And of course, now the world, you can now get data from all sources from all sorts of different places. So making sure that you can coordinate all of those things and understand their source, their progeny is important. Then we move into refining, taking all of that data, putting it into the machine in order to make sure that we create intelligence product out of the back of that. Then there's distributing it. How do we get it into the hands of the actual applications? And then finally, how is it applied to that end domain? And of course, that's almost the critical stage because, Ordnance Survey, we talk about how data is really, really important, but it has no intrinsic value in its own right. It's all about its extrinsic expression. In other words, how do I take that data, take it through all of that process of refinement in order that we can then apply it to a specific domain? And if you don't do the apply, there is no insight. If there is no insight, there is no value. So being very clear, I think, for us as an organization, but in the geospatial world more broadly, how does the value chain fit together is very important. And that's especially important now because of this ecosystem world we now live within. If you go back 50, 100 years, there were an awful lot of vertically integrated organizations and businesses. I mean, you owned the whole of the value chain, and we were one of those, right? We for the first 200 years probably of our lives, we owned the full value chain. We would have surveyors on the ground, boots on the ground, an army of surveyors, and literally it was an army, right? We would survey it, we would plot it, we would print it, and we would distribute it. And effectively, we provided everything to make the most beautiful maps in the world. And that meant actually from a purpose perspective is quite easy, So if the thing we're thinking about undertaking improves the map, if it did, we did it, and if it doesn't, we didn't do it. But of course, That's now changed, not just in our industry, but across the world. And that's really to do with the advent of computing. Computing now enables lots of organizations to connect at a very low transactional cost. So that means now an
Yes.
ecosystem can actually create that value chain through cooperation. So that then you can have specialists who are best, each one who's best at their little individual bit of the marketplace. That's true in hospitality and catering, as it is in road management, as it is in national mapping services. So that ecosystem, we have to also recognize now that we deliver value, that insight, the delicious meal on this end of the chain, through cooperation and through collaboration. So for anybody, when you're thinking about your value chain, then you've got to make sure you decide where is your disproportionate market advantage? Where do you want to play, and where do you then need to cooperate with others? Because again, if you're not deciding about where you play, you're cooperating with others, you don't know how you actually deliver value to the customer. And I suppose the other interesting point to add to that is that whereas, say, 20 years ago, geospatial was in a very specific swim lane, which was GIS systems. Yeah, in other words, it's for those people who've got the biggest, largest, most costly problems that need solving. They were the ones applying geospatial information systems. But now, actually, compute power is so prevalent and capable, we're seeing geospatial end
True.
up in all sorts of wide varieties of data analysis tools. And that's a great thing for our industry. But more importantly, that's a great thing for our country, our citizens, and the world. So now we need to consider the value chain, not just in the limited context of providing geospatial data to a small audience. Now we want to put that power in the hands of everyone. So that's how we think about optimizing value chain. And I would suggest it's probably how we as an industry need to start thinking about where do we play, how do we play, and how do we deliver and release that value for the world.
So my next question is stemming from the what you said about the cross-sector collaboration. So what role does cross-sector collaboration play in expanding the economic and social value derived from geospatial data?
Yeah, well, that really rather builds nicely, doesn't it, on that idea of ecosystem and value chain. In lots of ways, it's always been a bit like that. We have been, we've been we've been playing in that world of collaboration for many years between national mapping agencies. Why was I in India just before Christmas? It was to attend the excellent Geospatial World event there. And whenever you go to those things, you always come back with learnings. Actually, we need to do less of this and more of this, or that thing we learned up at Dehradun from the Survey General and the team of Survey of India. That's something that we can use and we want to. And the nice thing about that idea of collaboration, for me, that fits with the very connectedness of geography. Full stop. So I think, coming back to that point, understanding the value chain, understanding your place in that ecosystem, but then recognizing that different agencies within that network have different roles to play. I mean, within the UK context, it's Ordnance Survey. Ordnance Survey has an ability to convene an industry, right? So it's not been true in all of my roles, but I can now go into pretty much any meeting, whether it's in Whitehall and government or whether it's in private industry sector, and I can say I'm Nick from Ordnance Survey, and people sit up and listen. And that's an that's an incredible power, but also responsibility comes with that. So how do we then use the convening power of Ordnance Survey within the UK to make sure that we deliver better outcomes for citizens, better outcomes for individuals, better outcomes for organizations by connecting that eco system together? So that we don't think comes apart. That doesn't happen by accident. You
Mhm.
have to apply yourself purposefully to that task. And I think that may be something that we haven't recognized in the past, and we tried to carry on doing it all. But actually, the way our strategy now is set up, the more destinations that behind me, the better data, recognizes that we deliver that value for the country by working with as many other folks as possible, being that convening power. And again, I'd encourage all geospatial the whole geospatial industry to be doing that both at an international level, at a national level, and at a regional level. The very sense of where is that it relates to place. Yeah, I mean, it's in
Right.
It's on the backdrop behind you. We as an industry, more than any other, should be able to understand that the connectedness between those places, between those entities, but within that ecosystem, is the way that we can then unlock value and move and move the world forward. Maybe I'm just getting slightly ahead of myself, and we think our task is perhaps larger than it is, but I really don't think so. I think if we can deliver better services for the public, better industries that work well, drive the innovation, drive the technology, there's a massive unlock there. And I really think in geospatial, we're only just beginning.
So, coming to our topic, how is spatial computing transforming traditional industries such as agriculture, urban planning, and disaster management?
Sure. So spatial computing is a really interesting space, and I've been in the 3D industry since 1995. I think I took the job on the month they released Toy Story, and of course now we take 3D and actually more dimensions than just three quite happily for granted. Spatial computing. Before we talk, we talk about sort of the impact or the effect of it. We ought to be talking. Let me just define what we mean by spatial computing. It's a term that's been around for sort of 20 odd years, started in academia. And what I think the easiest way to think about it is it's about a blending of the real world and computing power. Now, if you compare that to the 1970s or the Commodore PET that I played on as a child in the late 70s, early 80s, you had to go to a place to use computing. Now, in the old days, that was a terminal for a mainframe. In my early 80s world, it was going to the table just outside my dad's study to go and play Space Invaders. But you had to go to a destination to access that computing. Never has it been thus. But if you think about what's happened in the smartphone era and now in the smartwatch era and the smart devices era, we're actually, computing is turning up in the place where you need it most. And that then actually means that you've got the right level of support for the human task that's ahead of you for what you're trying to achieve. So that stretches all the way to amazing inventions like the Vision Pro, Apple's augmented reality device. But equally, it could be much simpler than that. It could be a pair of glasses that I wear that when I'm trying to fit something in a car production line, it's got a green light and a red light, and it says whether I've got it right or I've got it wrong. The computing power now. So if you think about smart devices and you think about cloud compute and you think about readily available data, all of that stuff just works now. So now the question is, well, what's the task and how do we apply it? That comes back to our value chain question. That power, I think, is an unlock in the age that we now live. There's a chap called Maurice Conti, who is a sort of futurologist thinker, and he coined the term the augmented age. The era we're living in now is one that allows this connection between the virtual and the real world, between the digital
Right.
and the analog world in a seamless, invisible, ubiquitous way. And that means that then that humans and machines, this is his term, humans and machines partner to achieve more than either can achieve alone. Humans and machines partner to achieve more than either
Right.
can achieve alone. Now, clearly, we've had that in machines in the past. If I'm working on a car production line, I press the green button, it makes the panel of a car. But now we're talking about generalized computing. Now we're talking about a smartwatch on my wrist that can alert things just that are specific to me, that I have high blood pressure, that I've got an ECG monitor that's part of that, that's connected to my phone, that's connected to my health record in the cloud, that's connected to my local medical services. Spatial computing is the era we're now living in and is just happening transparently around us. Now, what's our role in that? Because there's spatial as in geospatial, right? And in order for that world to work, for that spatial computing to work, you've got to make sure the data upon which it's relying is trustworthy and is foundational, right? And also the uses of it have the appropriate ethical measures around that. Now, that's again a world I think we in geospatial we've been used to for years. We know that bad data
Yeah.
equals bad insights. We know that patchy data doesn't mean that we can provide universal service. We know that the data itself is not enough. We need that applied to that world. That's true all of those smart devices, for the AR headsets, for the VR headsets. And I think we as an industry should be representing that. We should be leading in that world. So what might that mean? Well, you mentioned precision agriculture. There could be a head-up display in the cab of your John Deere tractor that's making sure you're straight and true. Well, those things all have very sophisticated GPS capabilities in them. But they can have vision AI systems in there that can actually be saying, well, don't plow this way this time because actually or don't harvest there because that crop isn't yet ready. That's bringing computing. Previously the farmer, if he had a computer at all, would have to go back to his table at home and plot, well, what's my agronomy plan for the field at this time? We're going to distribute computing out into the world. We're going to see this blended world of the digital and the analog, and having good data coupled with good compute attached to that relates to the space is essential to deliver that. Now, if that's not that's not a problem we can solve, I don't know who else can solve it as an industry. What do we really understand? Well, we've been effectively capturing data from across the built and the natural environment for years. We've been assuring the quality of that data, and we've been plugging that data into real world applications. That's what you need for spatial computing. So I don't want us to be. I don't think we ought to be seeing that the spatial computing world is being driven by devices. I think it should be being driven by applications, and applications that are underpinned by foundational data that we as an industry know inside out. We know the value and the import of that data. We know the value and the import of keeping it up to date. We know the value and the import of making sure that it's trustworthy. That's something that we ought to be making sure we as an industry take to the world. That's definitely a role for Ordnance Survey, but I'd suggest it's a role for us as an industry.
Right. So, coming to the key challenges, what are the key challenges in scaling special computing solutions for global use?
Yeah, well, there are some challenges there, and often, people talk about compute power. Is there readily available computational capability to deal with the high bandwidth data associated, with all of the data that we have for the country? I mean, in the UK alone, we have half a billion features in our data stores that are being updated 20,000 times a day. That's reasonably high bandwidth data, and you need reasonably high bandwidth compute capability to do that. Well, one of the wonderful things that's happening in the AI revolution is, of course, that compute power is now being put in place. So I personally do not feel it's hardware and compute power that will be the limit to that. I think there are a couple of other areas that we do need to focus on. One is connectivity, so making sure that there can be a transparent connection between device and cloud, device, compute in the cloud, and data store in the cloud. But again, there's been an awful lot of work on that. I mean, you have to think about how you life cycle data, and then how do you make sure it's up to date? Am I getting the latest version of the data? Did someone go out and get some EO data yesterday that's relevant for my crop in my field today and now? So that connectivity, and I don't really mean at a base functional layer. I'm talking more about the way systems talk to each other, the protocols they use within that. But that's a progress that we're already working on as an industry. I think the second area there is actually more related to how do we drive the imagination of the end market so that they're making demands of us in the application, in the apply phase of our value chain, so that we can help build for those things there. And I think that is actually about democratizing the tools for geospatial understanding. There are geospatial covers everything from the really, really, really important matters of national security, national matters of national emergency, water, electricity, telecoms. We all rely on that geospatial understanding. That's a fantastically strong, fortified position by which to come from. But often the geospatial insights are ending up in a very small audience, and that's true even in the UK, where we've got a very strong expertise in this area. And yet everybody's got geospatial questions. And one of the things I talk about inside Ordnance Surveys, it's very straightforward to ask a geospatial question. Answering it is much more complicated. In that, a health provisioner might ask the question, where should I put a drop-in clinic for older adults who are suffering from dementia in this particular region? It's very easy to ask that question. In the same way, it's easy to ask the question, where should we go on Friday night? Answering those questions Now, where should we go on a Friday night is probably more straightforward, because we go onto a mapping application and we find a point of interest that we're going to go and see, go to that cinema, watch that show, and then we're going to have pizza afterwards at that restaurant. The ubiquity of that point of interest database is we should be able to answer more broader, almost more important geospatial questions as straightforwardly as that. And that health example is a good example of that. Education's got the same things, same questions. Business has. It should be as easy to run up to run up a geospatial to answer a geospatial question as it is to run up an Excel spreadsheet, and we're not there yet. That I think then creates a digital divide that we have to narrow. And again, I think it's our industry's task. We shouldn't just be satisfied with the reach that geospatial has within the very important industries it serves today. Geospatial, by its very nature, touches almost every aspect of modern global life. So that's certainly true in Britain, and I know it's true. In India and elsewhere as well. How do we make sure that it's as straightforward as creating a PowerPoint presentation or running up an Excel spreadsheet of actually answering geospatial questions? And in that world, I do think large language models, large multimodal models, the more modern transformer-based networks have a lot to help with there. We've got some wonderful internal projects here where, again, the Ordnance Survey is always trying to push the frontier of innovation and of technology. That we've got some demos that really do light that up. I think, and actually for me, large language models hold all their promise, less in the science, but now more in what's the problem we're going to solve. In lots of ways, it's an enabling technology. So now, as an industry, we have to say, well, what are the interventions that our customers and our markets want that large language models can solve for? How does that then relate to the geospatial? So for me, it's about opening up the world that we're used to in the geospatial world, but now let's make that available to the whole wide world.
Very nicely said. So, how can governments and private entities co-develop frameworks to foster innovation in spatial computing?
Yeah, well, I think we're in a rather privileged position here in the UK because we are an independent company, right? So Ordnance Survey, we're called GovCo. So we work very much like a tech business. In fact, internally we talk about we're a 200-year-old technology business, and yet we have one very important shareholder, which is the government. And so we have one foot in private land, we have one foot in public land, just like locations do. So if I think about my house I own, or the mortgage company owns, but effectively that's private property. But the pavement outside and the road outside is owned by the public purse and is run by the public sector. And yet those two worlds absolutely join at a polygonal interface. So of course the very nature of place is it's a collaboration anyway between the private and the public. So the wonderful thing about our setup is that we mirror the very sense of place. And that means that we can do things in entrepreneurial private sector ways, but do it with the assurance and the trust and the foundational aspects of public sector. And I think that actually provides a rather wonderful model that the rest of the world ought to be really looking at. We have a 10-year enduring contract with the government to provide that foundational trusted data sets for the country. And that's encapsulated within a contract. So that means that I don't have to go back to my government each year and say, well, this year we'd like to do this, this, and this. Can I have an extra 5% on my budget from last year? Because that settlement doesn't allow you to plan for long horizons. And of course, the one thing that's true for geospatial is that we're working on decades and centuries worth of activity. We're not working on a year by year basis. So I think the UK rather well provides that. That isn't just about the way that we deliver the national map. It also relates actually to the way that we drive innovation as well. So again, we fund PhDs at universities. We're very close to the university sector because we think in that university, and it's something the UK is particularly strong at higher education, there are some great ideas that we want to then support with the right sets of data, the right sets of capability, the right insights coming back from the market, in order to make sure that it doesn't just stay as university-based research, but actually ends up in being used in the real world and solving problems for real citizens and real folks and real people. So I think that you want a holistic solve for all of that, yeah? The independence of the organization, but with the deep support of government, the connectedness then to all departments, and actually being passionate and being evangelical about the task. That's something that I hope anytime you've met anybody from Ordnance Surveying, I was out there with David Henderson, our Chief Geospatial Officer, and if you think I'm passionate about this task, that David speaks about it times 10. That passion and energy to create better outcomes allows us to make sure that we can convene public sector, private sector, funding body, education, insights, innovation, in order to create really the heady mix that we need to deliver on that value chain that we talked about at the very start of this interview. That's a great opportunity.
Right. So, how is the increasing availability of high performance computing shaping the geospatial ecosystem?
Well, as I said, sort of, I think two questions ago or higher up in the interview, for me, compute power is there. Now it's down to the imagination of our industry about what problems do we want to solve for and how do we want to solve for those things. Mark Andreessen, I can't remember, it must be 15 years ago now, maybe longer, 20 years ago, he talked about how software was eating the world. In other words, everything where we used to apply hardware remedy to it, now actually you can do through software, from a telephone switch all the way through to security. So that for me is true today. Geospatial ended up in a very specific office within an organization because it was high bandwidth computing that was required. It required very specialist computing software and capability. Whereas now, actually, I think the deep prevalence of high quality data sets underpinned by foundational national data sets, coupled with everyday data analysis tools, there's a massive unlock there. And we shouldn't fear that as an industry. We should be running headlong, fast downhill towards exactly that future. So for me, the compute power's there. Now it's down to our imagination, our software skills, and our connectedness and the ecosystem to actually deliver against it. And do you know what? I'm delighted. As a software person, I'm delighted that that's now the situation we find ourselves in.
My last question is, how can partnership between academia, industry, and government accelerate the development of inclusive analytical platforms?
Uh, well, this builds on having the model right in the first place, right? So making sure that you have something in it for everybody, but also with a clear understanding about where everybody plays within there. And in general, I would say the biggest challenge there is not what's going on inside one entity. I mean, sure, there are some challenges there, and that's true in all organizations we've ever worked for. Sometimes there are some conflicting objectives, there's some office politics around that. But broadly, those things with good leadership and good alignment and good culture, they resolve themselves. The challenge is, well, how do you make sure you interface into those other entities? And that shouldn't happen by accident. That's something you have to attend to. Relationships work because you attend to them, and that's true for individuals as it is true for organizations. So I think we, again, as Ordnance Survey, but we as an industry, it comes back to that. We started here talking about value chain. We talked about ecosystem. We talked about how and where we play. Being clear about how and where you play, rather than trying to own it all, is the thing to do. Where do we have disproportionate market capability, a unique intelligence, a unique piece of IP, and play there and be the best thing at doing that than anything else, and then recognize where everybody else is brilliant. That's the world we now live in. If you take a sports analogy, we don't have to now. I don't have to be good at both being in goal as well as scoring goals. If we are the best central defender within our world, then let's go and find a Messi to play up front for us, a Frank Lampard in the midfield. I'm a Chelsea fan, and then a Peter Bonetti in goal. And I don't think anybody else will know who Peter Bonetti was, but he was the Chelsea goalkeeper when I was growing up as a boy. That's the point, is that previously we had to be good at all the positions on the field. We don't now. So let's be proud of how good we are at our task, and then redouble our efforts to make sure the team works well and plays well together. We do that right, we unlock not just for our country and our citizens, not just for our industry and its participants, but genuinely we solve the world's biggest problems. Do that, and I think we can all sit back in our retirement rocking chair and be happy with the investment that we made through our lives.
Thank you so much, Nick, for your time and this insightful conversation. We had a great time.
Hey, it's lovely. It's always lovely to chat to the team at Geospatial World. I've really enjoyed the conversation. So thanks for taking the time to participate. Great conversation.
Thank you.